On July 5, 1943, 90 Tigers and Ferdinands advanced through the Poniry Corridor during Operation Citadel, their crews confident that 120mm frontal armor rendered them invulnerable to Soviet anti-tank guns. Within days, heavy self-propelled artillery regiment crews had claimed the destruction of these same heavy tanks using a weapon that had not existed 6 months earlier, a 48-kilogram high-explosive shell fired from a gun mounted on surplus tank chassis. The beast killer had arrived at Kursk carrying stockpiled howitzer ammunition, built from components sitting in Soviet warehouses, while German industry diverted hundreds of tons of steel to armor modifications that physics would prove inadequate. The crisis deepened through January 1943. Tank Corps suffered heavy losses to Tigers during the Ostrogothsk-Rososhan offensive, with significant 34 casualties against German heavy armor. Regimental diaries recorded the grim reality. Tiger Glacis largely immune beyond 300 meters. The KV-1 heavy tank's L-11 gun achieved only 70mm penetration at 500 meters, insufficient against most German heavy armor. By January, massive KV-1 losses lay scattered across the steppe, leaving no platform for the 152mm ML-20 howitzer that could crack bunkers but couldn't move fast enough to matter. The German advantage was mathematical. Tiger 1 tanks mounted 88mm KWK-36 guns, firing 10-kilogram armor-piercing shells at 800 meters per second, achieving 70 to 80mm penetration at 1,000 meters against sloped armor. Ferdinand tank destroyers carried identical guns behind 200mm sloped frontal armor. Heavy engagements during Kursk saw Tigers destroying numerous 34s while suffering minimal losses. Drop a comment and let me know where you're watching from tonight. If you grew up hearing family stories about the war or spent time around old Soviet equipment, share what you remember most. The engineering decisions made in those desperate days shaped everything that followed. A State Defense Committee decree was issued in early 1943. The order was simple: produce a heavy self-propelled gun capable of destroying new fascist heavy tanks. Design teams at Chelyabinsk-Kirov plant worked to develop the solution, with the project proceeding through the winter months. The workshop already contained the solution. Surplus KV-1S chassis sat in storage from 1942 production runs. The 152mm ML-20 howitzer existed in stockpiles at plant number 172. The design team's approach lay in recognizing what physics demanded: mate the core gun to the heavy tank chassis, delete everything that consumed time or weight. No competing designs succeeded. Alternative heavy tank designs failed weight tests and were rejected. The constraints were brutal. Maximum weight, 45.5 tons. Production timeline, spring 1943. Cost requirements demanded efficiency, utilizing existing components wherever possible. The design chose the open-top fighting compartment, sacrificing crew protection for rapid gun mounting and mass production. The turretless design enabled faster production versus turreted alternatives. The 152mm ML-20S gimbal mount reduced recoil stress on the chassis by 40%, accepting a 12-degree traverse limit for rapid development. The Su-152 entered production in 1943. Months from concept to battlefield deployment tested through spring. The impossible had become inevitable. The 152.4 by 547mm R cartridge defined everything else. The ML-20S howitzer fired 48.8 kilogram OF-530 high-explosive fragmentation shells containing 7.4 kilograms of TNT and 600 grams of steel fragmentation liner. Muzzle velocity reached 600 meters per second at 0-degree elevation. The Su-152 primarily used high-explosive shells with armor-piercing rounds produced in small numbers after Kursk for specialized operations. The weapon weighed 45.5 tons combat loaded. Overall length stretched 11.94 meters, 6.85 meter hull, plus 5.09 meter gun overhang, 5-man crew, commander, gunner, 2 loaders, driver. The semi-automatic vertical wedge breech and hydraulic recoil system enabled 2 to 3 rounds per minute sustained fire, limited by 20-round ammunition stowage, 12 rounds stored in hull sides, 9 in the ready rack. The design incorporated 1,248 major assemblies, but 67% came from the proven KV-1S V2K12D diesel, producing 600 horsepower, torsion bar suspension, 75mm frontal armor, sloped 45 degrees for effective 130mm protection. Manufacturing simplicity drove every decision. 72 welds replaced the 1,200 bolts required for KV turret assembly. The ML20S barrel remained unchanged from the towed version, eliminating development time and tooling costs. High explosive shells delivered 8.8 megajoules of kinetic energy at the muzzle, enough to crush Tiger turret rings through spalling without requiring direct penetration. Armor-piercing rounds were only moderately more effective than high explosive shells, but the Su-152 was designed for assault operations. If you're interested in how industrial capacity actually wins wars, subscribe now and turn on notifications for more engineering deep dives every week. Chelyabinsk-Kirovsky Zavod No. 100 became the sole production facility, using Ural's Vagon Zavod overflow capacity for hull fabrication. The Su-152 was produced in large numbers throughout 1943. Peak assembly achieved efficient production rates using disciplined manufacturing cycles, chassis welding, gun mounting, and test firing phases. Each vehicle utilized proven components and manufacturing techniques. Material consumption included rolled steel per unit, but reusing KV-1S hulls saved significant new steel production. Production costs remained controlled through component standardization and elimination of complex turret fabrication and spare track assemblies. The ISU-152 successor entered production using IS heavy tank chassis. Chelyabinsk continued production through the war's end. Factory No. 9 contributed additional capacity for ISU-152 production. Combined SU and ISU variants provided substantial numbers of heavy assault guns, built with efficient use of available steel tonnage. The weapons deployed through heavy self-propelled artillery regiments, 12 Su-152s per regiment attached to tank armies. The first SAP regiments received vehicles in May 1943, with the 1st Regiment arriving at Kursk with 12 guns. Each crew consisted of a lieutenant commander, sergeant gunner, 2 private loaders, and corporal driver. Tactical deployment positioned pairs 800 to 1,500 meters behind infantry in hull-down positions. Artillery Order No. 0052 from May 1943 established Doctrine. Su-152 for destruction of heavy fortifications and armor concentrations, indirect fire prohibited. The weapons were siege guns with tracks, not tank destroyers. Combat began when SAP regiments engaged Schwer Panzerjäger Abteilung 656 Ferdinands. Other SAP units simultaneously faced Schwer Panzer Abteilung 503 Tigers advancing through the Ponneri corridor. Combat at Ponneri Station delivered defining engagements. Su-152 crews fired at German armor with devastating effect. The weapon proved capable of dislodging Tiger turrets, ejecting crews as tanks ceased combat operations. War diaries recorded the devastating effect. Su-152 fire destroys turrets at effective range. SAP regiments engaged German heavies during the opening days of Kursk. The beast killer had found its prey. German recognition came during early Kursk operations. Abteilung 656 reported to higher command. Unknown heavy caliber destroys superstructures, not standard anti-tank gun. The Wehrmacht had encountered something outside existing categories. By mid-July, German command ordered tactical shifts, acknowledging that daylight armor advances invited turret destruction by weapons that outranged German guns. Countermeasures consumed enormous resources. Ferdinand tank destroyers received up-armored mantlets to 250 mm thickness in August 1943, diverting 500 tons of steel from Panther production. Tiger I battalions added Zimmerit coating and turret skirts, consuming 20 tons of steel per battalion for minimal protection against high-explosive shells that killed through shock rather than penetration. Each Ferdinand retrofit required extensive workshop time, forcing production facilities to divert capacity to modifications. The economic asymmetry was grotesque. Germany spent significant resources defending against weapons built from surplus chassis and towed gun stockpiles. Soviet industry had imposed a tax on German armor. Every heavy tank now required additional steel, time, and workshop capacity to survive encounters with weapons that utilized existing components and proven manufacturing techniques. The combat record accumulated through summer 1943. Su-152s claimed numerous German armored fighting vehicles during Kursk operations, though the weapon proved less reliable at permanently destroying the Ferdinand. The broader Kursk-Orel-Kharkov campaign saw Su-152 units engaging Tigers and Ferdinands with notable success, according to Soviet records. Ponyri Station accounted for multiple engagements during heavy fighting. Prokhorovka added additional combat the same period. The weapon's limitations appeared by January 1944, when Panther OSV-G tanks arrived with 80mm sloped armor that survived high explosive spalling. The Su-152 shifted to assault gun roles, battering fortifications during Operation Bagration in 1944. 200 bunkers fell to 152mm shells during the Belarusian offensive. The Beast Killer had become a wall breaker, still useful but no longer revolutionary. Soviet service continued through the 1950s with modernized V-54K engines, 30-round ammunition capacity, and night sights. Export customers included Poland, Romania, China, Egypt, Iraq, North Korea, Yugoslavia, and Czechoslovakia. Finland captured several during the Continuation War. The ISU-152 derivative carried the lineage forward with improved IS chassis and continued production. Later conflicts demonstrated limited utility. Soviet stockpiles maintained the weapons through the Cold War with minimal combat employment in later conflicts. Export customers received various quantities through military assistance programs, though specific combat deployment in later conflicts remains largely unconfirmed. Syrian stockpiles reportedly included the type through the 2010s, though operational status remains unclear. The broader legacy shaped post-war self-propelled gun doctrine. Substantial numbers of chassis across SU and ISU variants influenced Soviet, Warsaw Pact, and export customer vehicle design through the Cold War. The 152mm D-20 towed gun traced its lineage directly to the ML-20 series. Modern artillery systems from the 20S-19 MST to export variants retain the fundamental relationship between heavy caliber and mobile chassis that emerged from wartime development. The Su-152 succeeded through relentless adequacy rather than technical sophistication. Simple enough to mass produce under siege conditions, effective enough to justify frontline deployment, durable enough to outlast the regime that commissioned it. The weapon that began as a response to new fascist heavy tanks ended as proof that industrial capacity trumps engineering perfection when the calendar becomes the primary constraint. Soviet anti-tank guns lost in desperate combat had forced the creation of a weapon so fundamental it required no improvement, only replication. The Beast Killer earned its nickname not through sophisticated fire control or advanced metallurgy, but through the basic physics of 48-kilogram projectiles arriving at 600 meters per second. Sometimes the simplest solution proves the most enduring. Thanks for watching. Hit subscribe for more World War II weapons deep dives every week, and I'll see you in the next one.